Scott's Geography Notebook. Did you want to try saying it?
Da, da, da.
So we've talked about surface and subsurface water, what it is, why we care. We looked at my lawn. We've talked about transpiration, how water goes up through the plants and out through the little leaves and escapes out, and that a lot of water is needed for that. The last thing I want to talk about in terms of our surface and subsurface water is our soil moisture and our soil moisture budget that we want to talk about. All right, we saw as we were looking at the water percolating down through the different layers that water does get down in and around all of our soil particles. So what we have here are all of our little soil particles. Okay. And what we're going to do is we're going to kind of look at some sequences going from the left to the right. It's going to be kind of dry, and then it's going to be more and more. Okay. At some point, we're going to have tons of water. If we overwater our soil, what we end up seeing is that every little opening in between every tiny little soil particle is completely filled in with water. Okay. This is soil that is completely saturated. When this begins to happen, then what we start to see is water pooling on the top. All right, it can't go down anymore. So the water starts to pool on the top, pooling on the top, right? As that starts to happen, then we start to see runoff. Okay. It's going to either flow downstream, flow down the canyon, or it's going to be the lawn that gets overwatered, and so it runs off onto the sidewalk. Or what also will happen is this water will start to go down to our groundwater through the process of percolation or infiltration. All right. And this is referred to as completely saturated. We've reached our field capacity. All right, now, where most plants don't like their roots all the way down there. The fungi and the other things that work with them, that's going to be making it harder for them to survive. The roots really like this golden region right in here. And in this area, there's going to be some pockets of water, but what we also have are pockets of air. So we're going to have our soil particles, and we're going to have that water that likes to stick to some of these different guys, but we also have the air that's mixed in there. And this is going to make your plants pretty happy. They like to be in here. My lawn is turning happy green. Water's not flowing over. So what do we see in this area? We have my soil, we have water, and we have these little air pockets. Okay. That's where our plants are happy. As the soil gets even more and more dry, we run into this region which we call the wilting point. And the wilting point, as the name applies, is where the plants start to wilt. They can't get the water. Wilting point. Sad plants. Okay, now, the idea is the water doesn't completely go away, okay? But you're not having any that the roots are able to go down and get to. The roots can't get at any of that, but there is this very thin little layer of water that sticks, because water has a bit of stickability to it. The water sticks to the outside of these soil particles. The roots cannot get that water. They're not able to break the bonds between the water and the soil particle. Okay? So there is water present, but roots can't get it. This makes them sad. We call that water hygroscopic water. hygroscopic water. So a quiz question might, for instance, say, at the wilting point, there's no longer water in the soil, true or false? Well, there is water, but the roots can't get to it because it's bonded to the soil. It's referred to as hygroscopic water. Okay, let's talk about this whole soil moisture budget, because we need some water to go in, and the roots are going to be pulling some water out. So let's think about this in terms of a model. Okay, so we're going to think about what's going in, and then what's going back out, and how we balance all of that. So if we think about our soil moisture as this bucket, then what we're going to have is we're going to have a few things that are feeding into this, right? If we want our soil to be moist, then we can do it the natural way. And the natural way is precipitation, right? It rains or it snows or hails or whatever it's going to be. Precipitation can go into there. The other thing is, if it's not cutting it, then we turn on the sprinklers and we get irrigation. Okay. Now, we're trying to reach the balance. Where'd our balance go? We're trying to reach the balance of having enough water there. We don't want to waste water and have it pool and run off because, then the city officials get mad. We'd like to have just enough water there. So we need to make sure that we have enough water there, and then the water is lost from that soil two different ways. One, it can go into the plants, and if it's going into the plants, it's being lost through transpiration. And if it's going just out into the atmosphere, then we refer to that as evaporation. Okay. Now, we know, depending on where we are, that this guy over here is going to be altogether seasonal. Here in California, we have very, very dry seasons, and we have very, very wet seasons. Okay? We also know that this stuff over here, that the transpiration and the evaporation, that depends on the humidity and the temperature and other atmospheric conditions like wind and so on and so on. Okay? So how do we get this just right? Because if we're farmers, or if we like to eat what the farmers have, we need to have this just perfect so that it can sustain the life for our little plant that we have right here. And we'll put one more leaf over here. There we go. Good. So we want our little plant to stay healthy in our soil moisture. Okay. Depending on where we are, sometimes we're going to need to come in with irrigation. For most of California, for the crops that we like to grow in California, the growing season, the time when the plants need the most transpiration, is the time that it's going to be the driest. Okay. And so as we look through the whole year, especially here in California, we need to overcome what's called a deficit. If we don't have enough moisture, then we have a deficit. Not enough soil moisture, deficit. If we have a surplus or extra water, well, then we call that a surplus. But it balances. As we're going through the whole year, we're going to have some times when we don't have enough moisture coming in because we have a lot of demand for that water to go back out. Other times, the plants aren't going to be growing. Go out and look at your lawn in December. There's not a lot of growth going on in January and in February for your lawn. So, even though it's raining, it's not taking advantage of all that moisture. It starts to build up a surplus. When spring starts to come, the plants start to grow, it starts to pull that water out. But then here in California, we stop getting precipitation, so we run into a deficit, and that's when we start to have to water the lawn so it doesn't turn brown. Okay, so we've talked about surface and subsurface water. We've talked about what it is that we're talking about, why we care, because we like food. We talked about transpiration. That's going to be pulling the moisture from the subsurface up through the trees, through the pretty leaves. And we talked about our soil moisture and that soil moisture budget and how it's important that we keep everything balanced so that our plants can stay healthy and pretty and green.